3.2 equations that reduce to linear form. So we're going to solve linear equations containing symbols of grouping, solve linear equations involving fractions, and solve linear equations involving decimals. So for this section, I used example 2C from the textbook, and it says 5x minus 2 times the bracket 4x plus 3, parentheses x minus 1, close the parentheses, close the bracket, equals 8 minus 3x. So the first thing we notice is we have several grouping symbols. We have brackets and parentheses. When you're using grouping symbols, you want to work from the inside out. So first thing we need to do is we need to distribute the 3 into the parentheses. So we have 5x minus 2, bracket, 4x plus 3 times the x is the 3x, 3 times the negative 1 is our negative 3, close your bracket, equals 8 minus 3x. Sorry about the it's alive, that's my son in the background. Okay, so because we have brackets still, we want to make sure we combine like terms inside the bracket. So the 5x minus 2 slides down. We had 4 x's and 3 more joined them, so we have a total of 7x minus 3, close the bracket, equals 8 minus 3x. Now we notice that we have a 2 attached to the bracket by multiplication property. So we need to first multiply in by distributing the 2 into the bracket. So we have 5x minus 2 times the, so basically you're seeing this, 7x minus 3 equaling 8 minus 3x. We are distributing. The bracket becomes a parentheses. So when you multiply, we get 5x minus 14x. Negative 2 and negative 3 is positive 6, equaling 8 minus 3x. When we get to this point, we notice that on the left side, we have like terms. So we need to combine our like terms. So we're adding our 5x and our negative 14, and we come up with negative 9x plus 6 equaling 8 minus 3x. So this is where you guys get to decide. You can move the variables to the left and numbers to the right, or numbers to the left and variables to the right. Because this is going to lead into inequalities later on, the best bet is to always move variables to the left side of the screen. So what we're going to do is we're going to add 3x to the left side. So we get negative 9 and positive 3 is negative 6x, positive 6 equaling 8. Subtract the 6 to the right, so get negative 6 over. So you have negative 6x equals 8 minus 6 is a 2. Divide both sides by negative 6. So we get x equals negative 2 over 6. But since that fraction can be reduced, they're both factors of 2, it reduces the negative 1 over 3. So your result is x equals negative 1/3. In example 3, we have 2 of them. We're going to do B and C of example 3. So B says x over 5 plus 3x over 4 equals 19. Notice that the denominators for both of these are different. So the reason I'm highlighting them is because there's a thing that it's called least common multiple. 5 can't go into 4 and 4 can't go into 5, but both of them are numbers that go into the number 20. So we're going to use our LCM as a 20, which means I'm multiplying 20 times each of them. So I'm writing a 20 outside a parentheses with my parts for each piece. In doing so, we become 20x over 5 plus 60x over 4 equaling 20 times 19, which is 380. The reason I did that is so we can reduce now. 20 divided by 5 is 4x, so we have a whole number. 60 divided by 4 is 15, with an x, we have a whole number. And we already have 380 as a whole number. We can combine our like terms. So 4x and 15x is 19x, equaling 380. And then divide both sides by 19. So 380 divided by 19 results in 20. So x equals 20. When we look at example 3, it says 2/3 times the parentheses x plus 1/4 equaling 1/2. So in this situation, the best bet first is multiply straight through. So think of this x, and I'm gonna rewrite it as 1 over 1 with an x. So I'm gonna rewrite it as 2/3 times 1x over 1 to make it a fraction, plus 1/4 equaling 1/2. In this situation, we are going to multiply the numerators with the numerators, the denominators with the denominators. So I'm gonna do 1 times the 1, 2 times the 1, and then the 1 times the 2. So I'm gonna write 2x over, we have a positive 2 here. And then you're going to multiply the denominators with the denominators. So 3 times the 1 is a 3. 3 times the 4 is a 12, equaling 1/2. The reason I did this is so now they are all fractions. And we're going to apply the same rule we did with the first one. So I'm highlighting my denominators. So we see a 3, a 12, and a 2. 3 can become a 12, 2 can become a 12. So our LCM in this instance is a 12. So I'm going to write 12 parentheses 2x over 3 plus 12, 2 over 12 equaling 12, 1/2. And we're going to apply the same thing, numerator with numerator, denominator with denominator. So 12 times the 2, that's 24x over 3. 12 times 2, another 24 over 12. 12 times 1 is 12 over 2. At this point, we can reduce our fractions. So 24 divided by 3, there's your 8x. 24 divided by 12, there's your 2. 12 divided by 2 is a 6. X is already on the left side, so we are moving 2, so we're subtracting 2 over. So we get 8x equals 6 minus 2 is a 4, and then divide both sides by 8. So x equals 4/8, which reduces to 1/2.